Welcome to today's Explainer. We're taking a dense, highly technical manual on shielded metal arc welding and turning it into a hands-on shop class. Think of me as your instructor today, so grab your gear and let's dive right in.
You know, the tools are all prepped, and the metal is sitting right here on the bench waiting for us. But the real question is, are you ready to make some sparks? Today is all about the tactile, physical skills you need to actually master the fundamentals of stick welding. Let's get to work. Now, before we even think about touching a machine, we need to lay down the absolute golden rule of this shop. Safety first. Arc welding can be seriously hazardous. Clean work areas, proper ventilation, and the right protective gear are completely non-negotiable. It is literally the only way to prevent a major injury when you're dealing with molten metal and high electricity. Here is our lesson plan for today. 1. Safety and machine setup. 2. Striking an arc. 3. Common welding joints. And 4. Troubleshooting bead defects. All right, part 1. Safety and machine setup. Establishing the foundation. Let's head over to the workstation and get your core equipment connected properly. It's actually a pretty simple setup. You really just need 4 main things. First, your constant current power source, which could be AC or DC. Second, the insulated electrode holder. That's the part you'll actually grip in your hand. Third is the workpiece itself, your metal canvas. And fourth is your work clamp, which you absolutely need to complete the electrical circuit. And hey, the physical order of operations here really matters if you want a good weld. First things first, clean your workpiece. Seriously, if there's rust, moisture, or oil left on that metal, you're going to have a very bad day later on. Next, place your work clamp as close to the weld area as physically possible. That ensures a strong, stable current. And finally, right before you start, insert your chosen electrode into the insulated holder. Moving on to part 2, striking an arc, the crucial first step. Okay, the machine is hot, safety gear is on. It's time to actually connect with the metal and initiate an arc. You've basically got 2 primary physical movements to get that welding current flowing: the scratch start technique and the tapping technique. Let's break those down. The scratch method is exactly what it sounds like. You just drag the electrode across the workpiece like you're striking a match, and then lift it slightly. This is actually the highly preferred method if you're using an AC power setup. Tapping, on the other hand, means bringing the electrode straight down to the metal and lifting it just a bit to establish the arc. Now, a quick heads up, as a beginner, your electrode is absolutely going to stick to the metal. It happens to everyone. If it sticks, do not panic. Just give your wrist a quick, sharp twist to snap it free. Part 3. Common welding joints, your welding canvas. So, with your arc successfully lit and humming with that sharp, crackling sound, let's look at the canvas where you will be laying down your molten metal. Almost every shop project boils down to a few basic shapes. The 3 foundational joint configurations you're going to encounter over and over again are the butt joint, the T-joint, and the lap joint. And keep in mind, these joints aren't always just sitting nice and flat on a table. They can be positioned flat, horizontally, vertically, or even overhead. Though I really want to emphasize that overhead welding is incredibly tough to master. Why? Well, gravity is constantly fighting you, trying to pull that molten metal puddle right back down onto your head. We'll definitely stick to flat welding before we tackle overhead in this class. All right, part 4, troubleshooting bead defects, the shop critique. This is where you really learn to become a craftsman. We're going to work backward from a failed weld to diagnose exactly what went wrong with your technique. For example, if your final weld bead comes out looking like Swiss cheese, full of tiny holes, well, you're dealing with a defect called porosity. Those are small cavities caused by gas pockets getting trapped right inside the metal as it cools and hardens. So, how do we fix porosity out in the shop? First, check your arc length. It was probably too long, so you need to reduce the distance between the electrode and the metal. Next, ask yourself, did you clean your metal? You have to rigorously clean off all oil, rust, and dirt. And lastly, check your equipment. A damp electrode is going to cause porosity every single time. Perfectly dry electrodes only, guys. Next up in the critique, excessive spatter. If you finish up and see solid metal particles just scattered and splattered all over the surrounding base metal, you've got excessive spatter. Now, a tiny bit of spatter, totally normal, but a massive spread tells you something in your process is way off. Usually, excessive spatter means your machine setup is running way too aggressively. To fix it, try decreasing your amperage right away. Or you might need to select a larger electrode to handle that amount of current. And just like with porosity, double check your hands. Make sure you aren't holding the electrode too far away. You really want to tighten up that arc length. Let's also look at how heat impacts the structural integrity of the joint. Good penetration means the weld metal nicely fuses the two base metals together with a solid internal grip. But with excessive penetration, the molten metal actually melts completely through the base metal and just hangs out underneath the joint. If you're melting entirely through the metal like that, you are applying excessive heat. You're just running too hot. The fix is pretty straightforward. Dial back your amperage, drop down to a smaller electrode, and adjust how fast your hand is traveling down the joint. Think about it. If you move too slowly, the heat builds up in one spot and blows a hole right through your canvas. Well, we've covered a lot of ground today, from safety and machine setup to striking that very first spark and diagnosing the resulting bead. Remember, every single weld you lay down in this shop leaves a permanent physical record of your setup, your angle, and your travel speed. It literally tells on you. So the ultimate question to consider as you step up to the workbench today is this: can you read the diagnostic story your weld is telling you so you can perfect the next one? Good luck making some sparks out there.